So, moin. Mal eine kurze Frage. Da draußen steht jetzt der Titel in Deutsch, aber es steht dran, das wäre in Englisch. So the title is in German, but it says it is in English. Who is German? Who wants to have it in German, or who is in English? I'm a bit confused what I should do. Or is it okay if that's in English? So you guys want it in English, right? What about you guys? Both is fine. So okay, then let's do that. Let's do that in English. That's easier then. So thanks for joining. Welcome to shift a bit your perspective, to look at some things in a slightly different way. That's the Danfoss motto this year on this Chillventa. It's about electric expansion valves for natural refrigerants, and then a little bit about the controllers as well, but mainly about the expansion valves. Well, when you hear electric expansion valves, most people might think about the valve itself, but it's never only a valve. It's always a complete system. So it's the valve, it's a controller that operates the valve, and then you have two sensors, at least two. Typically a pressure sensor, a temperature sensor, to be able to give a signal to the controller so the controller can handle the valve. So that's always the whole thing. When we talk about an electric expansion valve, it's always that complete subsystem, if you want to put it like that. The valve alone will not do anything. It's just sitting there and is a dumb part. Talking about that subsystem, well, there are quite some other things around that. So there might be the main controller of the system talking to the superheat controller. You have the superheat controller itself. You have maybe a programming stick. You might have a gateway for data communication and all of that stuff. You might have a battery backup. I come to that a little bit later, why you might need a battery backup. And yeah, in the middle of all of that is the expansion valve itself. Talking about the electric expansion valves, there are two technologies out there. One is a pulse width modulation, and the other one is a stepper motor. Pulse width modulation is kind of a solenoid valve. It's opening, closing, opening, closing, opening, closing all the time. So it's not constant. It's really opening, closing all the time. Quite often that's a 6 seconds period when the whole process restarts. So now let's do a simple calculation. You have 50% capacity, then it's 3 seconds open, 3 seconds closed, 3 seconds open, 3 seconds closed. And that gives you an average of 50%. Now if you have 4 seconds open, 2 seconds closed, 4 seconds open, 2 seconds closed, you come to 66% average capacity. If you have 1.4 seconds open and then what's left, 4.4 seconds closed, you do the math yourself. What's that percentage is? I don't want to do that. But that's how it works, right? So it gives you an average capacity by opening and closing. The stepper motor valve is different. You have a stepper motor which operates a spindle, and the spindle then opens up and closes down an orifice. So there's a cone which goes into the orifice hole. That means you can bring it to a certain position and then you have a constant flow, and the further you bring that cone into the orifice, the smaller the flow path is and the less refrigerant goes through that orifice. So those are the two technologies out there. And quite often you get the question, and which one is the better one? Well, there is no black and white answer to that, because then if for everything one technology would be better, then there would only be one in the end. But there are both. But let's have a look at a few points, some main points between these two technologies. And you see these 4 points there. Let's start with the first one, a simple electrical connection. Now, if you go to that PWM valve, I mean, I'm from Danfoss, as you can see, and that's why you see the Danfoss valve series is an AKV for the PWM, so the on and off valve, and is an ETS for the one on the stepper motor. So the simple electrical connection, if you have this PWM technology, which just goes open and close, you have two wires, like a solenoid valve. You just bring power and neutral. And whenever you power up the valve, it opens. When you power it down, it closes. So very simple connection. Simply two wires. That's it. If you go to the stepper motor valve, you need typically 4, sometimes 5 wires. And that's because you have different coils in the stepper motor. And then you need to tell each coil when to energize, to tell the valve whether it turns this way, so right or clockwise, or it turns anti-clockwise, whether you want to open it and close it. And then you need to give that signal in a certain speed, how fast you want to operate the valve, and so on. So that's not terribly complicated, but it is 4 or even 5 wires. So it's a bit more what you need to do. It's not only these 2 simple wires. Then we can look at the refrigeration system itself. If you have one compressor, one condenser, one expansion valve, one evaporator, so a single evaporator system, then the PWM valve, which is just opening and closing, is not really the best choice. It might work, but of course, whenever you open and close the valve, you get a pulsation. So you initiate pulses in the refrigeration system. The stepper motor valve, you bring that to a given position, you have a constant flow. That's, of course, then not initiating these pulsations. So a single evaporator system, the stepper motor valve has its advantages. If you have several evaporators in parallel, typical example, a supermarket where you might have 20 evaporators. Now you have this on-off valve in each evaporator. So of course they still have that on-off behavior, but as an average for 20 evaporators, each evaporator is acting a little bit differently. So as an average, that evens out. So the power pack of the supermarket will not really see any fluctuations because of these expansion valves. For a multi-evaporator system, the PWM technology works fine. Stepper as well. So they are on par there. And now we come to the fail-safe operation. In case you have a power outage, the valve that acts like a solenoid valve, the PWM valve, open, close, open, close. When you have a power outage, it falls closed, it is safely closed. Always. On the stepper motor valve, when you have a power outage, it stays where it is. It might stay at an opening degree of 60% and continues to inject refrigerant, which you might not want to have. If you do not want to have that, you need to add a battery backup to your controller so that even at the power outage, the controller has enough power to at least close the valve. So that's an advantage for the PWM system because it is fail-safe by itself. So as you can see, each technology has its pros and cons. Just normal life, right? But let's take a moment with that PWM valve, which opens and closes Danfoss AKV series. They are available, the title says, well, valves for different, for natural refrigerants. They are available for CO2, that's on your left-hand side, and for ammonia on your right-hand side. Different capacities, you can read the capacities yourself, so you can have them for quite large capacities as well. And then I mentioned this pulsation that you get. Whenever you close that valve, you stop the flow of liquid. It gives a pressure peak. That's simply what happens. However, in the latest series of these valves, in the latest AKV series from Danfoss, we have built in a dampening which reduces pressure pulse a lot, which is called the soft pulse technology. And you see the comparison here encircled in red. The upper one was the old version, the lower one is the new version. So you have a far lower pressure peak whenever the valve closes. And that is something you can even hear. In many systems you hear the pressure peak, you hear a click noise, and that click noise is kind of gone with the new series. So that is reduced, the pressure peak, but you can see there is still a time when there is no flow and there is a time when there is a flow. That's not going to change because that's the technology of the valve. It is just the pressure peak that is reduced. Here. I'm sorry, the throat is a bit gone in the last 2 days. So then let's jump to the stepper motor valve. They are available again for CO2 and for ammonia. Pretty large capacities as well. Especially ammonia, you can go to very, very high capacities with stepper motor valves there. And staying with these large capacity stepper motor valves, there is a motor on top of the valve, and that has a magnetic coupling. So you can take the motor away without opening the refrigerant circuit. So it's really completely hermetic. You can open that valve, change the motor, put a new motor on, or do whatever kind of service on the motor, bring it back, and you have not opened the refrigerant circuit, just to mention that. But okay, CO2, ammonia, those are not the only natural refrigerants. There are hydrocarbons as well. One of the hydrocarbons is R290, which is quite often used. And then this is the Danfoss lineup of expansion valves for R290. Starting with low capacities, going up to pretty high capacities as well. So even there on R290, you have a lineup of capacities that should hopefully suit what you need. So there's no gap, nothing. You can really find a good lineup there. So, and on the left-hand side, you see the valves. Two smaller ones, they have that blue coil. And there are other valves in the market, of course, which have coils as well. Other colors quite often, but they have these coils as well, so you can take off these coils. But the upper one looks a bit different. And I would like to have a short focus on the upper one, which in Danfoss is called the so-called colibri valve. That's abbreviation C here. And everything is inside the housing. So it's a fully hermetic valve. The motor is inside the housing. So there's no way that you can change any parts. And that was on purpose, because if you go back, these coils, you can change them, the blue ones, that's nice, but they sit in environments which sometimes are not healthy for coils. Here, the coil is inside, and we know exactly what the environment is. It is always refrigerant. There's no humidity in it, and so on. We know the temperatures, all of that, and that's why you can design something like that for a lifetime as well, that you don't need to do a service. Just to mention that this is a fully hermetic valve, made in stainless steel, by the way, inside copper, so you can solder that pretty good. Staying with that technology, stepper motor valves, there are a few points I would like to highlight. There are different curves, at least in the Danfoss portfolio. There is a so-called linear curve and the so-called S-curve. If you want, you can call that polyline, so made of several lines added together. The linear one is pretty easy to understand. It's kind of one line. Per step, you open that much. The other one is designed in a way that in the beginning you open less, And then at the end, you can open more. And maybe you want to open less in the beginning per step to have a better control at low capacities. That's the idea behind it, to have a more stable, a better control at low capacities. And that's why you get these two lines. You can choose which valve design you want to have. That's, of course, the mechanical design of the valve here. But you can choose which line you want to have. Staying with the line, I mean, this shows how it should be. Come on, there's reality. When you open the valve and when you close the valve, there's quite often a small difference, hysteresis. So you open, let's say, 200 steps, you are exactly at that point. You go down again, well, you might not be at exactly that point again, because there is that small difference. There's a mechanical operation in the valve. So there is a hysteresis. And that's what you see here. You would like to have a hysteresis which is as small as possible so that you always get to pretty much the same point. On the left-hand side, I have put in a dotted line, this thin dotted line, which shows how it should not be. You don't want to have the open line, let's say one of the red ones, and the closed one, the dotted line. That's what you do not want to have. You want to have both lines as close as possible sitting on top of each other, so that the valve is really repeating everything it should do, always in the same way. On the poly line, there are tiny differences, as you can see. But they are okay. A controller can handle that, and your system can handle that. If it would be that dotted line, that might be a bit difficult. If you go to the linear one, they sit on top of each other. You don't really see a difference. Those are measured results. Now, as mentioned in the beginning, you have to have a controller, a superheat controller. So let's talk a little bit briefly about the superheat controller. There are different superheat controllers available. These controllers you see now are for stepper motor valves, and then there are different sophistication levels. So there is a level where it's a driver only. That means your main controller of the system gives that one a signal and says, I want you to open 60%. The 60% might be a signal from 0 to 10 volt, for example. So you give it 10 volts, then this driver translates that into a signal for the expansion valve. The driver is really a translator from a standard signal into an expansion valve signal. But there are controllers which have an algorithm incorporated to do the full superheat control themselves. And that's then the other ones which are not called drivers. All the other ones have the superheat algorithm incorporated. You get controllers for 1 or 2 valves, that the same controller can drive 1 or 2 valves. The same accounts for the PWM technology. There are different controllers because they need to be able to do this on-off, open, closing. But basically, same idea with superheat algorithm available as well. And then superheat algorithm. There's one option to do a fixed superheat. That's on your right-hand side. So it's always the same superheat. That's that straight line that's going up. However, your evaporator could operate with a smaller superheat at lower capacities. You see this blue area? That's where you cannot really control. But outside the blue area, you can control. You get a stable operation of your evaporator. So in low capacities, your evaporator can live with a small superheat. If you go for a fixed superheat, you kind of have a too high superheat, unnecessary high superheat. That's why there exists an algorithm called MSS, Minimal Stable Superheat, which is searching by itself what is the lowest superheat I can operate with. I have illustrated that with that line on the other side, and it adapts to the lowest possible superheat by itself. So you run always with the highest efficiency. that's 2 out of 4 algorithms you have in the Danfoss controller. I just wanted to mention that there is a self-adapting one. And then if you want to select any components, there is a software called Cool Selector from Danfoss, where you have quite a lot of tools. Have a look into that if you want, and that helps you to select an expansion valve. So thanks for listening. Hopefully you got some interesting information here. If you want to have more information, Hall 7, Danfoss booth, come and talk to us. Thank you.